Okay, let's go to our final and third example, and you'll realize now that this is a little bit more difficult. Why is it more difficult? Well, let's look at the question itself. We've got a fraction, we've got limits on our integration. So this means this is called a definite integration. And that bit basically means having integrated it, we need to then put the limits in, and we have to decide whether they're 2 and 0 and find a value for our final answer. Okay, so we're going to start off as usual by writing u equals 4 plus 3x squared. We're going to then differentiate that as we did earlier. We're going to get du dx, in this case, is equal to 6x. We then make du the subject, and we have 6x dx, which we'll come back to later. Some of you might have recognized where we can go from now, having looked at the question, but I'll deal with that in a moment. Okay, so we're going to write out our question. Integration of 2x over 4 plus 3x all squared dx. Okay. Every component here. So we've got 2x, we have a dx, we have a 4 plus 3x squared, 3 components, all 3 which must be changed to an expression involving only u. Okay, but from earlier, if we look at this line here, surely there's a connection between 6x dx and 2x dx. And if we divide by 3, which is the obvious case, we can have 2x dx is actually equal to 1/3 du. Okay, so we can now write integration. We can have 1/3 there over u squared du. Even though that doesn't look very pretty at the moment, that has now been fully substituted. The best thing to do now is, like we did earlier, is pull the 1/3 out, and rather than having 1 over u squared, put it in indice form. So we have 1/3 integration of u to the power minus 2 du. Okay. So let me just write that last line again. So we've got 1/3 integration of u to the power minus 2 du. And you might have noticed that the 2 and 0 were not put in place. I've left that to the last minute. So whatever we do not worry about the 2 and 0 at the moment. Okay, let's integrate this u to the power minus 2. So when we integrate u to the power minus 2, we're going to get u to the power minus 1 over minus 1, in other words, times by minus 1/3. And to tie that up, we can have minus 1 over 3u. That has now been integrated. Put that in square brackets. Now we are talking about definite integration here, as opposed to indefinite. So rather than changing the u back to x, if you look at the question on the right hand side, the 2 and the 0 actually should not be placed here. And that's another common misconception made amongst some students. The 2 and the 0, as you can see, belong to x. But we need to have new boundaries that belong to the letter u. Well, we know that u equals 4 plus 3x squared. So it makes sense for us to put the upper limit x value of 2, which you see on the question, and replace it here. If you put 2 here, 2 squared times 3 add 4 becomes 16. So that 16 can be put on the upper value for the u. Likewise, the lower value, lower limit on the x is 0. So we replace the 0 here. 0 squared times 3 add 4, naturally becomes 4. And what we've done now, we've changed the boundaries that belong to x to now belonging to the letter u. As you can see, it has to match with this letter. And this saves us time of rather than changing the u back to x. It's much easier this way. So all we've got to do now is plug the numbers in. 16 becomes u, so we're going to end up with minus 1 over 48. Take away, really important, put brackets for our second input. 4 goes into place of u there, we have minus 1, 12. And then the rest is quite simple. You have minus 1 over 48, add 1 over 12, and that's going to be clearly a value of 3 over 48, which becomes 1 out of 16. The exact value for this question is 1/16. Thanks for watching. Please leave any comments in the comment section below. Don't forget to give this video a thumbs up. And if you haven't done so already, please subscribe to the channel. And remember, please share this with your family and friends. Thank you very much.